All right, so let's go ahead and talk about section 4 when we're talking about nonlinear inequalities. Whenever we have something that is nonlinear, we're going to be talking about a process that is called key numbers. Okay, so when solving nonlinear, in this case, right, not on a line or absolute value, we're going to be dealing with inequalities. So again, we need our symbols. Right? You must use a method called key numbers to solve. So this includes quadratic inequalities, rational inequalities, and cubic inequalities. So let's talk about a quadratic. So I can have x squared plus 6x plus 5 is less than or equal to 0. Or we can have a rational, so this is my fractions. I have x plus 5 all over x minus 3 is greater than 0. I can have a cubic, so I can have x cubed plus 6x squared minus 4x plus 7 is less than 0. So all these would be examples where, in this case, right, it is not linear, so we are going to have to go ahead and implement the method of key numbers. Okay. Any number that makes the equation equal to 0 or undefined, that is our key numbers. So steps for solving nonlinear inequalities with using the key numbers, right? I guess I could show you like why it wouldn't work. If I were to go ahead and split this up into two things, right, here's my number line, -3 and 2, where both of them are going this way. Okay, sometimes the reason why key numbers does not work is because there might be times where in our expression, this might not be true, right? I can't just say, okay, -3 to infinity and call it a day, right? There might be other intervals where, in this case, right, now we're dealing with inequalities where x values have to be positive, so there might be some part in here where it's not true, it's not going to be positive, so that's what we have to go ahead and find out. Okay, so I'm going to go and leave the positive aspect in there. The way that we do key numbers, step 1, if necessary, go ahead and rewrite the inequality so that 0 is on the right-hand side. Okay, that's already done for us, we don't have to do anything. Second step is find the key numbers for the inequality and locate them on a number line. The way that we find our key numbers, it's basically finding the roots. So kind of like the same thing, x plus 3 is equal to 0, x minus 2 is equal to 0. So then my key numbers in this case is going to be -3 and 2. And again, I'm going to go and find these guys on my number line, -3 and +2. Okay. Step 4, it says from each interval, step 3, it says list the interval determined by the key numbers. So this interval is going to be going from -infinity to -3, soft bracket. This interval is going to be going to -3 to 2, soft brackets, then 2 to infinity. Okay, as you guys get more practice with this stuff, you might not even need to have the intervals for each specific key number, but it's always good to have. Step 4, it says from each interval to go and choose a convenient test number, and using the test number to determine the sign of the polynomial throughout the interval. Okay, so every single interval is going to have a test number. And usually with the test numbers, I usually just go to the one right next door. If you can use 0, 0 is just an easy number, so I would go ahead and do that. But my first test number is going to be -4. My second one, I'm just going to make it 0. And then my third one is going to be a 3. And basically, I'm going to go ahead and plug these numbers, these test numbers in to this guy right here and see if it's going to be positive or negative. Okay, so my first test number is -4. I'm thinking -4 plus 3, that's a negative number. -4 minus 2, also negative. Negative times a negative gives me a positive. Same exact thing with 0. 0 plus 3 gives me a positive number. 0 minus 2 gives me a negative number. Positive times negative gives me a negative number. Test number 3, I have 3 plus 3 is a positive. 3 minus 2 is a positive, so overall gives me a positive number. Okay, so I just did step number 4. Step number 5 is to go and summarize your results on the number line. Again, we are looking for positive values, so I'm looking for these specific intervals. Okay, so my answer in this case is from negative infinity to negative 3, union 2 to infinity. Okay. Now, if you're like, okay, well, like, what does this even mean? If you guys were to go ahead and FOIL this out, right, it is a quadratic, so you guys don't have to draw this. But in your quadratic, or I guess I can just do it on one line, it has the x-intercepts at negative 3 and 2, right? So this is my graph of that right there. And basically, you're looking for the x values that are positive, right? From negative infinity to negative 3, here are my positive values. From negative 3 to 2, it is negative. And then from 2 to infinity, right, is also positive, okay? So you're just looking for these specific intervals that make sense given to your expression. So if you want to look at it graphically, you totally can. Otherwise, you can always go through this process. Eventually, the expressions are going to get a little bit more tougher, so going through this process that we just did together will be probably better than looking at it graphically. Okay. All right, I'm going to go ahead and erase this guy, and let's go ahead and do example 2. All right, example 2, same exact thing. This time around, we are going to have to go ahead and factor. So I'm going to go ahead and factor by grouping. I'm going to take out an x squared, so we're left with an x minus 3. Take out a negative 4. X minus 3 is all less than or equal to 0. X squared minus 4. X minus 3. And then we do have a difference of squares. All right, so now my key numbers, it looks like, is going to be negative 2, 2, and 3. So here's my number line, negative 2, 2, and 3. This time around, I'm going to have 4 test numbers. Let's do negative 3, 0, 2.5, and then 4. I can go ahead and write my intervals from negative infinity to negative 2, hard bracket, negative 2 to 2, 2 to 3, and then 3 towards infinity. All right, let's go ahead and test out the numbers. So again, I'm plugging it into this guy right here. All right, so I have a negative 3 plus 2 is... Negative 3 plus 2 is a negative. I have a negative 3 minus 2 is negative. Negative 3 minus 3 is also a negative. Negative times negative is a positive. Times a negative overall is a negative. Test number 0. 0 plus 2 is positive. 0 minus 2 is negative. Negative overall is a positive. 2.5 is a positive. Positive, negative. Overall negative, and then test number 4 overall will give you a positive. Okay, same exact thing. If I'm looking at my original expression, we are looking for a negative value. So I'm looking at my intervals that are negative. So therefore my answer is going to be in negative infinity to negative 2, hard bracket, union, hard bracket, 2, comma, 3, hard bracket. And this is your solution. All right, let's go ahead and skip down to, let's do example number 4. So example number 4, it's the same exact process. However, now we're dealing with a rational, right, a fraction. So if I'm looking at my original one right here, it looks like we're looking for negative values. Same exact thing. I'm just finding my roots. So I get what? Negative 1/2 and 4. So my key numbers is going to be negative 1/2 and 4. So I'm going to go over here. Okay, test numbers. I'm going to do -1, 0, and 5. And this time I'm going to go ahead and plug it into my original one right here. Okay, so -1 times 2 is a -2 plus 1. Negative. -1. So this is going to be a positive. Right? 0. Positive, negative. Overall is a negative. Cool. Test number is 5. Overall, it should be a positive. All right, again, you're looking for the negative interval. So this time around, it's going to be hard bracket -1/2, 4. And 4 is a soft bracket because if I plugged back 4 into my original one, right, it would have 0 in the denominator. So that would not be a hard bracket. All right, go ahead and try example 3.